Guys, and welcome to today's class. And if you were in the last class, we talked about atoms, molecules, and ions. And I took out my time to explain what an atom is, what a molecule is, and we gave a clear distinction between atom, molecules. I also told you what an ion is. And if you paid attention to the last class, I told you that an ion is formed when an atom loses or gains an electron. We gave example, let's say oxygen atom. And of course, you know that the atomic number of oxygen is 8. So if you are arranging the electrons in the shares of oxygen, of course, you know, I told you that the first share usually contains 2 electrons. Second share is supposed to accommodate 8 electrons. Second share. Okay, remember the electron number for a neutral atom of oxygen. We are having 8 electrons. So out of this 8, you're already having 2 here, remaining 6. So it means this outer share. And if you paid attention to last class, I told you that this outer share is called the valence share. And the electron in the outer share. Somebody asked me a question that what is the meaning of valence electron? Valence electron is simply the electron in the valence share. In other words, the outermost shell of an atom. That's what you call the valence share. So whichever electron you have in that valence share, that's what you call the valence electron. So this oxygen atom having 8 electrons, we have already filled these 2 electrons in the first share. Second share, we fill the remaining 6 electrons and 6. Now you can see that we need 2 more electrons to make oxygen attain a stable octet structure. And I've already explained what an octet structure means. So we need 2 electrons. Remember, I told you that every atom in each share, we are supposed to have 8 electrons. But here we're having 6 electrons. So it means that oxygen actually needs 2 more electrons to complete this outermost share. All right. So what oxygen will do in order to attain this stable octet structure is to get an extra 2 electrons from another atom that wants to give out. Let's say, for instance, calcium. Okay, calcium has 2 electrons in the outermost shell. Let's assume this is the outermost shell of calcium. You are having 2 electrons here. Okay, so let's say the both of them goes into reaction. These 2 electrons of calcium will be donated to this oxygen atom, so that this one will attain a stable octet structure. The same thing here, this one will also attain its own stable octet structure. So now that this one has calcium already lost 2 electrons, it becomes an ion, and oxygen here too also gain extra 2 electrons. It also becomes an ion. Now the difference is between them is that one will be forming a positive ion, while the other one will be forming a negative ion. So this one that is giving out will form a positive ion. So that's why we have calcium to the 2+, telling you that calcium has already lost 2 electrons. So this one that is gaining, oxygen, will form a negative ion. So if you see something like O2-, it means that oxygen has gained 2 electrons. Okay, oxygen has gained what? 2 electrons. But this is not what we'll be talking about. This is just like a revision of what we did last week. So what we'll be talking about today is relative molecular mass. Okay, before we go into this relative molecular mass, let me just quickly introduce you to something. How to calculate mass number of an atom. Please take note of this formula. Mass number of an atom is equal to proton number plus neutron. Proton plus neutron. Please take note of this formula. Mass number is equal to proton number plus neutron number. I told you that proton number is still the same as atomic number. Atomic number of an atom is the same as the proton number. So if the atomic number of oxygen is 8, it means the proton number of oxygen is also 8. And we'll talk about atomic number. I told you the arrangement of elements in their order in the periodic table. The number each of them falls under. That is what you regard so as their proton number. For instance, hydrogen is number 1. It means the proton number of hydrogen is 1. Oxygen is number 8. It means the proton number of oxygen is 8. Calcium is number 20. It means the proton number of calcium is 20. Just like that. Just like that. So if they ask you what is the proton number of magnesium, you only just to recite the first 20 elements. The number magnesium falls under. That number is the proton number. Okay, now for mass number is the summation of the proton number and what? The neutron number. And if you also pay attention, I told you that For a neutral atom, number of electron is equal to number of proton for a neutral atom. But if you have a negative atom or a positive atom, the number of electron is no longer equal to the number of proton. For instance, this oxygen atom now, O2 minus, this is a negative ion. So the number of proton here is no longer equal to the number of electron here. In this case, we have added 2 more electrons to this. Initially, we're having 8 electrons, neutral atom. We had 8 electrons. But this neutral atom gained 2 more electrons. It means that the number of electrons here, now that it has become an ion, the number of electrons here is now 10. While the number of protons still remains 8. Then in this case of calcium, calcium has already lost 2 electrons. Okay, initially we have the number of proton for calcium to be proton number of calcium to be 20, and the electron number when it was neutral is also 20. But now it has become an ion. 2 plus simply means that it has given out 2 of its outer electron. So now that it has lost an electron, so it means we have to subtract 2 from this. It has lost 2 electrons to become 18 electrons, while the protons still remain 20. So in this case, when calcium has already turned to an ion, the number of proton is not equal to the number of electrons. But at the neutral state, when it has not lost or gained any electron, the number of proton is equal to the number of electrons. Please take that, take it, so jot it down. Mass number is equal to proton number. Back to this number, this formula. If you are asked to calculate the mass number of an atom, any atom at all, the mass number of any atom, if you are given the proton number and the neutron number, just sum the summation of the proton number and the neutron number gives you the mass. Okay, let's take, for example, we're asked to find the mass number of an atom X. They gave us the proton number. Let's say proton number is 20 and the neutron number to be 15. And they say find the mass number. We already know the formula that mass number is equal to what? Proton number plus what? Neutron number. So we already have the proton number to be what? 20, and the neutron number is 15. Getting the mass number is very simple. Summation of the proton number and neutron number gives us mass number. So we have this to be equal to 20 plus 15. So our mass number is equal to what? 35. That's all. So you see the calculation is very simple. Mass number is equal to the summation of proton number and what? Neutron number. In some cases, they can give you the mass number. They can give you the mass number, then you will be asked to find the neutron number. Okay, so let's assume the mass number of chlorine atom, the mass number is 35, and then they give us the proton number to be 17. They say we should find the neutron number. We already know that mass number is equal to proton plus neutron. Mass number equals to proton plus neutron. Mass number is 35. It was given from the question. Proton number, we know it to be 17. Even if they not give you this proton number, they so only give you this element. You should know the proton number of chlorine, because chlorine is actually number 17 in the periodic table. So you have this to be 17 plus neutron number. Collect like terms, move the 17 to this place. So you have your neutron number to be 35 plus 17. So it means the neutron number is equal to, if you subtract 35 plus 17, that gives us what? If you do this subtraction, 15 minus, that will give us 828. That's all. So we'll still come back to this. Of course, I always give you questions at the end of every lesson. So after you have watched, you will solve more. Please learn this. If you not get the explanation, if I were you, I would backward the video so that I will get the explanation, because I'm going to give you problems on this to solve for me later. Okay, back to relative molecular mass. This is the actual thing I want to teach today, how to calculate relative molecular mass. I just feel you should know this one first. Back to relative molecular mass. Now listen, pay attention. Calculation under relative molecular mass is very simple. And if you do not know this calculation, relative molecular mass, so other calculations in chemistry will become very difficult for you if you don't know how to do this, because this is like a basic knowledge for every chemistry student. Okay, if you don't know how to do this, you will struggle in other topics that requires calculation. You will struggle with it, because you will need the relative, in most calculations in chemistry, you need relative molecular mass. Okay, if you don't know how to do this, you will struggle in other. So if I were you, I would listen attentively. Okay, relative molecular mass of compounds relative molecular mass of compounds. Now, pay attention. There's what we call relative molecular mass and relative atomic mass. You need the relative atomic mass of elements to solve for relative molecular mass. Now, relative atomic mass, they are usually constants. Okay? If you open your textbook, you see them there. They tell you hydrogen is 1, hydrogen helium is 2, hydrogen lithium, I think is 4. It's constant. Oxygen is 16, chlorine is 35.5, magnesium is 24, calcium is 40, just like that. They are constant there. Potassium, I think, is about 30. So please, and in most calculations, they usually give them to you. Okay? They usually give them, but I advise to them to learn the basic ones like oxygen. You should know the relative atomic mass of oxygen. Now, pay attention. Relative atomic mass is different from atomic number. Don't confuse the both of them. They say relative atomic mass. Obviously, they are constant. Atomic number. So I'll also explain how you get atomic number. For instance, if you are listing the first 20 elements, number 1 is hydrogen. Number 2 is hydrogen, helium. 3, you have lithium. 4, you have beryllium. 5, you have boron. 6. Like that. Now look at this. You see this number 1, hydrogen. That's with the atomic number of hydrogen. It is 1 because it is number 1 here. Atomic number, this is relative atomic mass. Helium is number 2. Atomic number is 2. Lithium is number 3. Atomic number is 3. Beryllium is number 4. Atomic number is 4. And remember I said the atomic number is also the same as proton number. So if the atomic number of beryllium is 4, it means the proton number is also 4. Boron is number 5. Atomic number is 5. Proton number is 5. And if it's a neutral atom, it means that the electron number is also 5. Okay, but if you now say relative atomic mass, of course hydrogen is 1, but it's not because this one is number 1, that's why it's 1. Like this one is I think it's about 2 or 4 if I'm not mistaken. It should be 4. Yeah, 4. This one is 7 or so. So you can see they are constant. Everything is in your test. You can download the relative atomic mass of the first 20 elements. You would have them there. You will see everything. The relative atomic mass of the first 20 elements. You see everything. You will see everything will be listed for you. You see, it's in your textbook. If you have new school chemistry, and also, in fact, any chemistry textbook, you will always see the relative atomic mass of elements. They are there. All elements have their relative atomic mass. So make sure you know them. And like I said before, in most calculations, they will always give you in brackets. After they've given you the question in bracket, they'll tell you calcium 40, magnesium 24. All the elements you need to solve that question, they will give you their relative atomic mass. Okay, so I believe you know the difference between these three types. So you'll not be confused. But what is the atomic number of helium? You will not be giving me the relative atomic mass of helium. They are different, please. Okay, relative molecular mass. Relative molecular mass of a compound. First of all, let me start like this. Relative molecular mass of relative molecular mass of an element is simply the relative atomic mass of that element. If you have this element, let's say magnesium, I say calculate the relative molecular mass of magnesium. It is the same as the relative atomic mass, 24. Yes. But when this atom becomes a compound, let's say magnesium, or let's say we have HCl, hydrochloric acid. This is a compound now. Combination of two elements gives you a compound. So if you are asked to calculate the relative molecular mass of this compound, it will now be the summation of the relative atomic mass of the individual elements in the compound. What do I mean? The summation of the relative atomic masses of the individual elements. In other words, you bring the relative atomic mass of hydrogen plus the relative atomic mass of chlorine. If you add them together, that gives you the relative molecular mass of this compound. But let me come again. The relative molecular mass of a compound is simply the summation of the relative atomic masses of each element that makes up that compound. Please jot it down if you're writing. Let's take an example. So let's say we were asked to calculate the relative molecular mass of CaCO3, calcium triisocarbonate 4. CaCO3, we are asked to calculate the relative molecular mass of this. And like I said before, in bracket, they will always tell you that Ca is equals to 40, comma, C is equals to 12, and O is equals to 16. Now, all these values that I've given here, they are simply the relative atomic mass of calcium, 40, relative atomic mass of carbon, 12, relative atomic mass of oxygen, 16. They will always give to you in the question. So how do we calculate the relative molecular mass from these given values? It's very simple. Remember the definition I gave to you, that it is simply the summation of the relative atomic masses of each of the elements that makes up the compound. So it means that the relative molecular mass of CaCO3 would that be relative atomic mass of Ca plus relative atomic mass of carbon plus relative atomic mass of oxygen. Remember, you have 3 here. That is, you are multiplying this oxygen by 3 times 3. You can put it in bracket like this. So you have calcium to be 40, you put your 40 here, plus carbon is 12, you put your 12, plus oxygen is 16, 16 times 3. So you have 40 plus 12, plus this times this will give you 48. If you add everything, if I'm not mistaken, it should give you something like 100. 12, this will give you 12 plus 48 will give you 60 years. So 40 plus 60, everything gives you 100. So 100 is simply the relative molecular mass of CaCO3. Okay, please you do this for me. H2SO4 tetraoxosulfate C acid. H2SO4. Find the relative molecular mass of H2SO4. I know somebody will now be telling me that what is the relative atomic mass of hydrogen. I've already told you that hydrogen is 1. Sulfur is 32, and oxygen is 16. So I've already given you the relative atomic mass of each of the elements that makes up this compound. And from these given values, you should be able to calculate the relative molecular mass of H2SO4. This is what we call tetraoxosulfate C acid. With time, I will teach you how they got that name for this tetraoxosulfate C acid. Because some persons are like, where is the C coming from? There's no C here. Where is the C coming from? I will soon teach you that one. But then do this one and drop your answer in the comment section.